Here's part 2 of your semester exam review. Number 25, got another robot question. The question below uses a robot in a grid of squares. The robot is represented as a triangle, which is initially here. The following programs are each intended to move the robot to the gray square. Program 2, here, uses the procedure goal reached, which returns true if the robot is in the gray square and returns false otherwise. Alright. Which of the following statements is true? Program 1 correctly moves the robot to the gray square, but program 2, okay, let's see what these two programs do. So program 1, repeat 4 times. Move forward, rotate left, move forward, rotate right. So that's going to, every time that happens, that's going to end us up here, right? Move forward, rotate left, move forward, and then rotate right. So then that's going to do that again. After 2 times, it'll be here, 3 times, 4 times. So that will get us to here. So program 1 correctly moves the robot to the gray square. That's true. Now let's see what program 2 does. Until goal reached, if can move forward, else rotate left. Okay, so that's going to move forward, and then if I can move, so until goal reached, goal is not reached, so it's going to do this again. If can move forward, yes. And then if can move forward, yes. If can move forward, yes. And then we're going to rotate left. Once we get to here, when we get to if can move forward, no, we can't, so it's going to go to the else statement. So then it's going to rotate left. So that will rotate this way. Be oriented this way now after we rotate left. And then I'm going to go if can move forward, yes. If can move forward, so that's also going to get us to here. So it looks like both programs are going to get us to the gray square. So the correct answer would be C. 2 ways to get there. Both work. Alright, number 26. Which of the following describes a benefit of using hexadecimal numbers instead of binary numbers to represent data? So before I even look at the answers, hexadecimal numbers, in binary you have like 1, 0, 1, 1, 0, 1, 0, 0, something like that. In hexadecimal, that would only be 2 characters, right? This would be, let's see, what is this? This is 11, so this would be B, and that would be 4. So that would be B4. So it takes less characters or less symbols to represent the same number of bits. So hexadecimal can be used to represent fractional values, but binary can only represent integers. Well, that's not true. Binary can represent fractions too if it's some kind of like floating point binary. So hexadecimal and binary can do the same things, just depending on how we interpret them. Hexadecimal can be used to represent a wider variety of data types in binary. I mean, hexadecimal and binary are representing the same thing. It's the same information, so that's not true, the wider variety. Hexadecimal is easier for a computer to understand than binary is. That's definitely not true, because hexadecimal is easier for us to understand because it's less zeros and ones to look at, right? It's more like a higher level of abstraction. A hexadecimal representation of a value generally requires fewer digits than a binary representation of the same value. That is true. Right, these 8 digits only required 2 in hex. Number 27. A programmer notices the following two procedures in a library. Library is like when you've been programming in Python, when you call up the when you introduce the library math or random or something like that. So the procedures do similar but not identical things. Procedure square n, so this might be like in the procedure math, or in the library math rather. So procedure square n returns the value n squared, and cube n returns the value n cubed. Okay? Which of the following procedures is a generalization of the procedures described above? Procedure add m, well don't do addition, that's not what they're doing. Procedure fourth, that would be like maybe another procedure in this library, but it doesn't generalize what these two do. Procedure polynomial, no, adding those together, that's not a generalization of that. Procedure power nm, which returns the value n to the m. That would generalize these because you can do either one of these. This would be power n comma 2, and this would be power n comma 3. So both of those could be done with this procedure here. So that's like a generalized one that just takes a number and raises it to any power, not just 2 or 3, but anything you want. Oh. Looks like I lost another number here, so I guess this is going to be number 27.5. Sorry about that. This code segment below is intended to display all multiples of 5 between the values start and end, inclusive. For example, if start has the value 35 and end has the value 50, then we should get 35, 40, 45, 50. Assume that start and end are multiples of 5 and that start is less than end. Okay? So we're going to record I, the start value, into I, and then we're going to repeat some number of times. So we'll need to figure out what that is, and then display I, and then increase that by 5, and then we're going to repeat that number of times. So how many times do we need to repeat it? So let's take this example. So if start is 35 and end is 50, then how many times did we want to do it? 1, 2, 3, 4 times. So obviously the difference between these is important. So 50 minus 35 is equal to 15. And then since we're counting by 5s, if I divide that by 5, that's 3. But then I need one more time than that because I want to get that last value. I wanted 4 here, and this just gives me 3. So I think we want the end value minus the start value plus 1, divided by 5, and then plus 1. So this is the correct answer here. And this is the kind of question where, like, you could try, if you weren't sure what to do with this, you could just try these different options using the example given. So end minus start, that would be 15 plus 1. That would repeat this 16 times. That's no good because that's going to give us 16 different multiples of 5 starting from I. So you can just go through and try those. But end minus start, and then divided by 5, sorry, divided by 5, and then plus 1. That's what's going to do it. All right, the real number 28. Consider the following program. Okay, I'm going to start my count at 1. There's a sum that's set to 0. Repeat 10 times. New sum is equal to sum that's starting at 0 plus count, count starts at 1, and then I'm going to increment the count by 2, and then I'm going to repeat that 10 times. So when count, let's see, so sum is starting at 0, and then I'm going to add count to it. So it's going to be 1, and then I'm going to increment it by 2, and then I'm going to repeat that again. I'm going to add count, which is now count started at 1, so now count is 3. So I'm going to add 3 to the sum. Sum is equal to sum plus count. That'd be 4, and then I'm going to increment count by 2, so now count is 5. So then sum is equal to sum plus count. So that's I'm gonna keep adding like the next odd number. So this was like plus 3, right? Because count went from 1 to 3 in the first iteration, then plus 5, and then it's gonna do plus 7, then plus 9, and then plus 11, and so on. Okay? So I don't really like any of those answers there compared to what I did. So let me go back and check and see. So count is equal to 1. So let me just scratch that, and I'm going to make a little table because I didn't like what I got there. I'll be a little bit more methodical here. So count is equal to 1, sum is equal to 0. I'm going to repeat this 10 times. So what happens to sum? Sum is equal to sum plus count. And then count is equal to count plus 2. Right? And then I'm going to do it again. Sum is equal to, so I guess that is doing what I did here. So let's see, the program displays the sum of the even integers. No, definitely not. It's definitely not doing anything with even integers. The program displays the sum of the odd integers from 1 to 19. I think it's doing the odd integers from 1 to 19. So is that in fact what I'm getting? So this would be 4. So I guess that's true, because this is 1 plus 3. Yeah, that's right. This is right. And then 1 plus 3 plus 5 is this, and then 1 plus 3 plus 5 plus 7. So there's a cool fact that if you add up the sum of a bunch of odd integers, you get the perfect squares. It's kind of cool. But just tracing through that program, you can see that that is what's happening. So a couple of things to kind of direct you to the right answer here, things to notice as you're trying to do your code tracing through this, is that the count is going to be odd numbers, right? It's starting at 1, and then I keep adding 2 to that. So that's 1 plus 2 is 3, plus 2 is 5. So it's definitely about odd numbers. And then if it's repeating 10 times, then it can't be adding the odd integers from 1 to 9, because that's only 1, 3, 5, 7, 9. That's only 5 numbers, and it's repeating 10 times. So that could also direct you to this. All right, number 29. A student wrote the procedure below, which is intended to ask whether a user wants to keep playing a game. The procedure does not work as intended. All right, so procedure keep playing. Display, do you want to continue playing? Yes or no. And then we get an input from the user and store that as a response. If response is equal to y and response equals yes, Okay, so let's stop right here. If response equals y and response equals yes, the response can't equal two different things, so that is always going to be false. This Boolean expression, this and this, it can't be both of those, so that would be always false. So that's never going to happen, else return false. Which of the following best describes the result of the running procedure? Since the input going into response here is going to be whatever the user types in. They're supposed to type in y or n, but whatever they type in, it can't be equal to this and this. So this is never going to return true, because this condition here, if something is equal to something and something different, that cannot be true. This is always false. So that's the correct answer. How could you fix this so that it worked correctly? If you change this to or, then it would work right. All right. The procedure below searches for the value target in list. It returns true if target is found and false otherwise. So we're just checking to see if this is in the list. Okay, so procedure contains, and then the inputs into this procedure, the parameters, are list and target. So this is the list, and this is the thing we want to see if it's in the list. So for each element in list, if element is equal to target, then return true. And then it's going to go through the whole thing, it's going to go through all of them, and it's going to return false. So if it doesn't ever hit this return true, when you hit a return in a procedure, that's the end of the procedure. It returns that, and then the procedure is done. So if it gets through all of the elements in the list, and they're never equal to target, then it will get to here. Okay? So which of the following are true statements about the procedure? It implements a binary search. No, binary search is where you have a whole bunch of list items and you start searching in the middle, and then you're like, oh no, it's less than that, so you split the difference, and then you keep splitting the difference, and kind of like you would look for if you're leafing through a dictionary trying to find a word, you open it up, and if you're like, nope, that's too far in one direction, then you back up and so on. That's kind of like how a binary search works. So this is not doing a binary search. It's doing a linear search, which means it's starting here and it's going through each element in a straight line through the list. So yes, it's doing that. It only works as intended when the list is sorted. It doesn't matter if the list is sorted or not, because it's going to go through, for each element in list, it's just going to go through all of them. So whether it's sorted or not, doesn't matter. So correct answer is B. Number 31. Program contains the following procedures for string manipulation. All right, we've got this one, Concat, so probably that puts these two together. It returns a single string consisting of string 1 followed by string 2. For example, concat key and board returns keyboard. So that's what concatenation is. It's putting two things together. So it'll take two strings and join them up. Substring, string, start, and length returns a substring of consecutive characters from string, starting with a character at position start and containing that many length characters. The first character of string is located at position 1. For example, substring delivery 3-4, so that starts at 3 and gives us 1, 2, 3, 4. So it's giving us that. That tells us where to start, and that tells us how many letters. Okay? Which of the following expressions can be used to generate the string happy? So if we concatenate substring harp11, so that's going to take this string, start at the first character, and then keep one character only. So that would give us that. And then substring puppy, start at 2, and then take 4 letters from there. And then it's going to concatenate those two. So that would give us huppy, which is kind of close. I don't think that means anything. It's like a happy puppy. But that's not what we're looking for. We want it to give us happy. So concatenate substring harp. So substring harp starting at the first character and then taking 2, give us that. And substring puppy starting at 3 and then taking 3 characters. And then if I concatenate those, that's happy. That looks like that's the right answer. Let's just make sure. We'll check the other two. So substring harp 1, 2, that's starting at 1 and then taking 2 letters, because that's what that procedure does. Substring puppy, start at 4 and take 2 characters. So that's going to give us a misspelled happy. No good. And then here, substring harp 2, 2. So that starts at character 2 and takes 2 characters. And then substring start at 4 and take 2. So that's arpy. So the correct answer is B. I think that question is really about understanding procedures and what this means to like pass parameters into a procedure. Right? Question number 32. A programmer is developing a word game. The programmer wants to create an algorithm that will take a list of words and return a list containing the first letter of all words that are palindromes, which are a palindrome is a word that reads the same forward or backward, like mom in this list here. Mom is a palindrome, kayak, because it reads the same forward and backward, level, apple is not, banana is not. I guess it says that later in the question here. Okay. The programmer in the returned list, the list is of the first letter of all words that are palindromes. Okay, so the returned list here, since kayak, mom, and level are palindromes, it would return K, M, and L in alphabetical order, K, L, M. Okay. So the programmer knows that the following steps are necessary for the algorithm, but is not sure in which order they should be executed. So step shorten takes a list of words and returns a new list that contains only the first letter of each word from the input list. And then we've got this, it's called step. These are like procedures really, right? Keep palindromes. Takes a list of words and returns a list that contains only the palindromes. And then sort takes a list of words and returns a copy of the list in alphabetical order. Okay, so what do we want to do? We want to, if we want to make this list, the first thing we need to do is get rid of the things that are not palindromes. So this is the first thing we need to do. Keep the palindromes. And then we're going to sort them, take a list of words, and returns a copy of the list in alphabetical order. And then we can shorten them. Although I think that we could, if we did the keep palindromes first and we shortened them second, and then we put that shortened list in alphabetical order, I think that would work also. So I think that has to happen first, but then I think the other two, it doesn't matter what order we do them in. So executing which of the following sequences of steps will enable the algorithm to work as intended. I think we need to keep palindromes first. Because we definitely can't, oh, actually, maybe we could sort first too. So let's actually go through all these and just see. If we first shorten them and then keep palindromes, if we shorten them only to the first letter each first, then like a one letter, like something like K, like that technically, that's a palindrome because it reads forward and backwards because there's only one letter. So if we shorten them first, then everything's going to be a palindrome, so that's not going to work. But maybe sorting them first. This definitely works, so keep the palindromes, then shorten them, and then sort them. That will work. So what if we did it this way? What if we sorted them first, so put them in alphabetical order, then keep the palindromes? Well, they'll already be in order then, so the ones that we keep will be in alphabetical order and then shortened, so that should work also. So 2 and 3 both get the job done as intended. So approaching a problem like that, I think you just maybe want to try the 3 and think about what each one of those would do, whether it accomplishes the goal or not. All right, these last few, these are the ones where we have 2 answers. Here in the directions, and every single time we're going to get a reminder to select 2. Okay, so 33, which of the following are ways in which a programmer can use abstraction to manage the complexity of a program? Okay, so abstraction, it's like making procedures, making things higher level. So replacing each instance of repeated code with a call to a procedure. Definitely, that sounds good. Instead of having like a new block of, like the repeated block of code every time you use it, you could write a procedure that does that. B, replacing longer variable names with shorter variable names to reduce typing errors. No, not really, because longer variable names can often be better descriptors of what's going on, and be actually better at abstraction, better at like telling us, like if you have, instead of calling something n, you could call it number or whatever. So longer variable names are often preferred because it's easier to read the code and understand what those variables are. What if you're replacing several lines of documentation with a single line of documentation? Documentation is like comments in your code. So if you replace a bunch of documentation with a single line, that's not really helping to manage complexity. That's just like making your descriptions of what your code does shorter, which could be a bad thing. So that does not seem right. Replacing all the string variables, name 1, name 2, name 3, and name 4, with a list of strings called names. That is something that would help manage complexity. Instead of having a bunch of names like that, then you make one list that's called names that replaces all that. That would help manage the complexity. And you know, in fact, in your mini create task, that's one of the things that's required to use a list that helps to manage the complexity. So that's definitely a thing that we are thinking about. We have been thinking about. So A and D are the right answers there. Number 34. The program below is intended to count the number of prime numbers in a list called numbers and display the result. The program uses the procedure isPrime n, which returns true if n is a prime number and false otherwise. I feel like you've seen a question really similar to this recently. The program does not work as intended. Okay, so it's supposed to return true if the number is prime and false otherwise. And a prime number has, remember, definition, prime number is divisible only by 1 and itself. Okay, so count is going to start at 0 for each value in numbers. The number of prime numbers in a, okay, so we're counting the number of prime numbers in a list called numbers. So for each of the value in numbers. So this is one of the values, one of the numbers in the list. And we're going to cycle through this for loop for each one of those numbers. And then we're setting count equal to 0 again. That seems kind of weird that we did that twice. If is prime value, so it is prime returns true if n is prime. So if is prime value, then we're going to increase the count by 1, and then we're going to increase the count by 1 outside that. That's weird. Okay, so there's 2 lines of code that should be removed. So definitely there's 2 different setting the count equal to 0, and there's 2 different increments. So one of these has to go and one of these has to go. So let's think about that. I think that we don't want to reset the count to 0 inside this loop, right? So we want to set the count to 0 and then increment the count so that we want to increment the count somewhere in here, but we want to set it to 0. If we keep resetting it to 0, we're not going to get the count because we're going to keep resetting it to 0. So that needs to be outside the loop there. And then if is prime, then we want to increment the count by 1, but we don't want to increment it outside the loop because if it's not prime, then we don't want to do that. So we want to get rid of lines 4 and 9. So B and D are the correct answers. Right, number 35. The program is created to perform arithmetic operations on positive and negative integers. The program contains the following incorrect procedure, which is intended to return the product. That means multiplication of integers x and y. So that's x times y. That's what we want it to do. So procedure, multiply x and y. Count is equal to 0, result is 0. Repeat until count equals y. So result is equal to result plus x. And then count is equal to count plus 1. Return result. Okay. So let's see if this, let's just try this. I'm just going to try if we did multiply this procedure 2, 3. So those were the x and y. That should return 6, right? So let's just see if it works. So the count is 0, result is 0. Repeat until count is equal to y. Count is equal to 0 right now. So result is equal to result plus x. So that would give us a 2, right? It starts at 0, and I would add 2. And then the count is going to go up by 1. And then I'm going to do that again. So return, so that's going to give me 4. And then add 1 to the count, and then it's going to be 6. And then after I do it 3 times, count is going to be equal to 3, so count will equal y. So, okay, that works for multiplication because, in general, because it's going to take that number and add it to itself that many times, right? Repeat until count is equal to y. So 2, 4, 6. Then return result. So that works. Under which of the following conditions will the procedure not return the correct product? So it seems like if they're both positive, then it works. And we're looking for the ones where it doesn't work. So when they're both positive, like 2 and 3, works. What about positive and negative? Okay, so where do we run into problems here? So what if we did multiply 2 and negative 3? So repeat until count is equal to y. So I would start out, result is equal to result plus x. And then count is equal to count plus 1. So count is now equal to 1, right? Because it started at 0. And then, oh, and so the problem here is I'm going to keep adding to the count, and I'm going to repeat until count is equal to y. But y is negative 3. If I keep adding 1 to the count, it's never going to be equal to a negative number. So this is just going to go on forever, because that's never going to, we're never going to reach this until condition. So this does not work when y is negative. I think when x is negative and y is positive, I think it will work. So if we did this, then result is, those are both equal to 0. Result is equal to result plus x plus a negative number, so that's going to be negative 2, and then the count's going to go up by 1, and then I'm going to add x to that again, and I'm going to add x to that again, and then the count is going to be equal to 3 now, so that is equal to that. So I think it looks like the problem is when y is negative, because we're adding 1 to the count and then trying to get count to equal to y. So if you're adding 1 to that, that's not going to happen if y is negative. So then y's are negative. Those are the problems. So B and D are the correct answers, right? That's not return. And the last one. The procedure smallest is intended to return the least value in the list numbers. The procedure does not work as intended. Dang it. All right, this procedure smallest, and then this is a list. So minimum is equal to numbers 1. So we're going to take the first thing in the list and we're going to make that equal to minimum. And then for each number in the list, so for each one of these in the list numbers, if number is less than minimum, then return number, otherwise return minimum. Well, that doesn't work, because if, let's say, our list was, let's see, let's say our list was that, then what is this procedure going to do? It's going to take minimum and set it equal to the first thing in numbers, right? So it'll be equal to 5. Minimum will be equal to 5. So for each number in numbers, if the number is less than minimum, then return number. So the problem here is as soon as you get to a return statement, that's the end of that procedure. It's going to return that thing and that procedure is done. So when I get to here and I check this one, if number is less than the minimum, which we set equal to the first thing, then it's going to return number. But that's not the smallest thing, because the smallest thing is somewhere later in the list. And then if it gets through everything in the list, then it's going to return the minimum. So I guess it would work if the first thing in the list happened to be the minimum. So for which of the following values of the list will smallest the list not return the intended value? Select 2 answers. So I think in this case, it's going to set the minimum to the first one, and then although it doesn't really, the logic of it isn't right, it is going to return this because it was the first one. So that one, it does actually work. Here, the second one, we're going to set this equal to the minimum. And then for each number in numbers, if number is less than minimum, so it's going to return the first thing that's smaller than that. So this one, it's going to return this. And that is actually the smallest thing in the list. So although, again, the logic is wrong, it is going to return this because it's the first one that's smaller that it comes across. But for these two, this one, it's not going to work because it's going to make this the minimum. And then that one, you're going to, if number is less than min, it's not. 40 is not less than 30, so it's not going to do that. It's going to go through again here. It's going to return this. That's the first one that it came across that's less than this. For this one, it's going to return 30 because that's the first one it's going to come across that's less. So for which of the following values of the list will it not return the intended value? So it doesn't work for C and D. It gets lucky on these two, not because it's doing any kind of working properly, but just because the smallest value happened to be near the beginning of the list. There you go.